Like you said, we're going to talk a little bit about forage sampling and analysis. I guess first and foremost, we have many different kinds and types of forages, whether it be bales or bunkers or a forage that's actually standing in the field. We're going to go through and kind of look at how to properly sample those different situations. So we want to, the whole objective of collecting a sample is to get a representative sample of the lot or whatever the cattle are actually going to be consuming. So basically we're going to take a lot of bales or a bunch of silage or a field and boil that down into one Ziploc bag that you're going to take into and get tested at a lab. So the problem with that is there can be a lot of error, so we want to minimize that. So there's two sources of error when we do that, and that's taking the sample and then handling the sample prior to the analysis. So we're going to try and minimize those two things. Just quick schematic here. Basically, we want to be down here in this high precision and high accuracy. If we're just grabbing, for instance, some grass off the side of the bale and sticking it into a bag, we're probably not going to have very much accuracy in that. We're probably not going to have much precision in that. We'll talk a little bit about some forage sampling devices too. So the whole idea of this is to be highly precise and highly accurate so we know what you're feeding them cattle. Okay, so what is a forage lot? So basically it consists of forage harvested from one field, and not just from one field. I'm sure some of you guys have some fields, alfalfa fields that may be on the edge, have a bunch of weeds in them or some foxtail that grows up. So we kind of want to keep those separate. So usually contains fewer than 100 tons of hay. A forage lot should be, so we want similar forage types and similar soil types. We want them cut within a 48-hour period. You want to be the same maturity, same variety. Again, I mentioned the weed infestation. If there's some stuff maybe in a draw that's heavily infested with weeds or brome or whatever the case may be, we want to sample that separately. So like I said here, and for one instance, we have a hay field, one whole hay field, and we do have a draw, an edge of the field, whatever. Bale those and store them separately as a different lot, and then we have another hay field, obviously a different soil type, maybe potentially a different variety. We have grass infested. Maybe we didn't quite get it done because it got rained on. So we had some bales that got cut, started raining, we weren't able to finish it. We should store those differently and have a separate lot number for those and sample those separately. So we want to, again, like I mentioned here, we want those different lots. We want to group those bales together by the different sources, quality, and all that stuff, and also by a risk management. So when we get some of those summer annual forages, maybe we get a frost or maybe there's some hail damage on them, we want to store those separately as well and test those for nitrates potentially in the future. Yeah, we want to sort and store those. Okay. So how do we do this? How do we accomplish this? Basically, the best way to do it, especially when we're talking about bales, is a hay probe. I brought a couple of examples. We'll look at some, but they come in different shapes and sizes. This one doesn't have the tip on it. I'm getting it replaced. Here's another example of one. Basically, a lot of them nowadays go onto a drill bit, or go onto a cordless drill, or even preferably a corded drill. We talked about that last fall. If you can get a generator, that helps a lot if you can plug those in. Also, this one comes with an extension, allows you to get a little farther into that bale. So with that, so we want to sample that as close to feeding as possible. So if you know you have some bales in the back of the lot and they're a different lot number and you know you're not going to feed them this year or maybe for several months, don't worry about sampling those now. You can sample them when it gets closer to the time you're actually going to feed them. So rule of thumb, we basically want to sample 10 to 20% of the bales out of a lot. So if you have 100 bales, we want to sample at least 10 of those, up to 20 of those. And we want to do it randomly. We don't want to just take the first 10 we walk up to, because obviously that's probably not a representative sample of the whole group. Approved sampling devices. Like I said, there's many options. It's a small picture. I don't know, was there 15 to 20 different options that you can buy. They're not super cheap. I think this is the Penn State probe. I think they can run over $100 to $200 depending on what device you want to get and how complicated you want to get. But they do come in handy. The bad thing about some of them is they do take a little bit of elbow grease. So I found out you want to keep those tips sharp, because if you don't have them sharp, you're going to be there all day. And if you are using a cordless drill, you're going to go through a lot of batteries. So if you are going to sample hay, have 2 or 3 fully charged batteries to get through a lot. Or even better, a generator with a corded drill. That works much better. So the reason we do not want to use just going up to that bale, grabbing the last outside portion of it, is we want to get a good leaf to stem ratio. Because if you go up there and grab the outside of that bale, more than likely you're just going to grab a bunch of stems. Not a very good representation of what the actual bale or lot is. Okay, so weather damage on large round bales. Most damage occurs on the outside 12 inches. So what does that mean? 50% of the hay in the bale with a radius of 30 inches is in the outer 9 inches of that bale. Okay, so we want to get in there as far as we can. Like I said, we do have, some of them do come with this extension, which is nice to get a larger proportion of that bale sampled. Here's a nice schematic we have of a bale. If we look at the outer 4 inches, if we only take the outer 4 inches of that bale, we're only taking 25% of the sample. If we go to 6 inches, we're looking at 33% of the bale. If we get up to 12 inches, we're taking over half that bale, and 18 inches, which is what this standard hay sampler is. This is an 18-inch probe, so you can get in 18 inches on that bale, and you'll be taking 75% sample of that bale. And obviously with the extension, we can increase that even more. So this is looking at some unprotected large round bales and the sampling depth, and basically how that weathering affects the dry matter digestibility. If we look at the outer 3 inches on a bale that has been weathered, the dry matter percentage is 56%. A lot of moisture in there. Okay. Next thing we look at is in vitro dry matter digestibility is at 43%, and then our NDF and ADF, so our fiber portions, are at about 60 and 45. As we move inward on that bale, we're getting more dry matter. Obviously, less moisture is going to penetrate as we get farther into that bale. Our digestibility also increases, and with that, our fiber portions are decreasing. So we're getting less fiber, we're getting more digestible. So getting a representative sample of that whole bale is very important. If we take our 3 inches and take that to the lab, we're going to be adding some distiller's grain or corn or whatever you're using to balance a ration, and where you get this number, we're going to be adding a lot more distillers and corn than we probably need to be doing, and we're wasting some money. So sampling, so that was all round bales. So let's look at these square bales. It kind of looks like they're leaning there. So again, safety matters. Be cognizant of that. Leaf stem ratio is most consistent on the ends. So when we look at these bales, we want to drill directly into that bale from the ends, not from the sides, not from the top, straight from the ends of those. Again, these drill styles, hay probes work very well for that. Okay, so sampling silage. We have a large pile here. How do we handle that? Or maybe we have a pile that's covered up. How do we handle that? Also, we have silage that's in bags. Another question is, how do we handle all those situations? So we can sample it during harvest. We want to check the dry matter, basically how much moisture there is, and ensure that we're going to get a proper ensiling on it. So we want that at about 30 to 40%, right at 35% dry matter, or 60 to 70% moisture. There's different ways to do it. Coster test machine is one. Microwave is another. I don't recommend using the microwave at your home. Your wife might get mad at you. You can use an oven. Basically, you're going to take that, weigh it before you put it in the microwave or the oven, whatever the case may be. Leave it in there until it's dry. Weigh it again. You take the difference and divide it by the total weight, and you get your dry matter percentage. We don't want to take that sample until 28 days after that was first ensiled. We want to let that ensiling process happen and get the correct nutrient analysis on it. So silage safety, again, we talked about the square bales falling over. I'm sure every year there's probably someone that dies because they're doing something like this, or they maybe get close to dying because they get trapped into a silage avalanche. It's very dangerous. We don't want to be these guys. Okay, so the proper way to do it is get a payloader or a skid steer or whatever you're using. You know, if your pile's not too tall, it's not as much of an issue. But if we start getting to these taller piles, we want to be using a payloader to scrape the face of that silage, get it away from the pile, sample it out of the bucket that way, take 3 or 4 samples from a bucket, and then take a couple trips if need be. So if you are getting silage delivered to your farm, maybe you're purchasing it from a feed yard or someone that has a large supply of it, we want to sample that from the middle of the truck. Okay. Silage bags. These can be difficult to sample because we get them in the bags, we close them up, leave them in there for 28 days. What's the best way to sample that? You're taking out the front, so basically what you're going to use that day, and how do we handle that? So different days, different condition, it's hard to tell. We want to grab from the face from 8 to 10 locations. We get that first part out of there, you open the bag, we take that first part out of there. It's possibly a little spoiled, so we want to get into that bag a little ways and take samples. And we want to sample multiple times throughout the day as you're feeding. Another option is using our probes here again, probing the sides of the bag. A lot of guys don't like to do that because it's going to create a spoiled area along those bags. So not the best option, but if it does work. Say standing forage. How do we sample standing forage of a annual, maybe a summer annual you have, or some wheat grass? How do we sample that? Okay, so we want to again get a representative sample of the field. Not easy to do. We want to determine what the livestock will eat. Again, that's not easy. We try to do that on the university level with cannulated animals. We turn them out there well, first we got to empty out the rumen, turn them out there, leave them out there for several minutes or maybe up to an hour, bring them back in, and we see what they ate. It's not a very fun job. So trying to figure out what they're going to eat is very difficult. Whole plant samples, don't just go out there and grab by the roots and pull it up and you get a bunch of dirt on the plant and in the bag. That's obviously not the best way to do it. We want to clip them at the same height, roughly at what they're going to be grazing at and leaving out. So 3 inches or so, I think, is about what the recommendation is. Use clippers, okay? So once we get those clipped, that's how we clip them. So we don't want to just go out there and clip one area and call it good. We want to walk, there's 2 ways we can do it. We can walk a diagonal line across catty corner, across the field, and take 1 plant sample every 50 to 100 steps. Or we can do it another way, take it out of the 4 corners in the middle. And that'll get you a pretty good representative sample. Okay, so once we get those samples, you're throwing them in a bucket or a bag or whatever as you get through there. We want to cut them into 1 to 3 inch pieces in a clean bucket, mix it up, put them in your sample bag. So whether it be a 1 gallon sample bag or one you get from the lab. So something like that. So we get some questions fairly often, or I get called out and I got to sample a pile of hay. And sometimes those piles of hay don't have one kind of hay, or might have a little bit of wheat straw, might have a little bit of brome, and it's just a potpourri of different hays. So how do we sample that and to get a representative sample? So we do a composite sampling. We want to take, if we can, can't go back. If we can, sample that as you're grinding it. That is a good way to do it, and taking different samples as you grind it and placing them off to the side, and then mix that up, or in a bucket, and mix that up and sample it that way. So composite sampling, we want to take a similar weight or volume of samples on different days and times. So this would work well for a bag of silage, works well for. We take those, place them in the refrigerator for 3 to 5 days as you're feeding. We want to take about the same amount and weight or volume each day, mix it into a bucket, again, putting it into your bag and sending it off to the lab. So final thoughts here. Forage analysis is often overlooked. So it's easy to say, well, I have an average quality alfalfa, so it's 55% NDF and 55% digestible and maybe 20% crude protein. But in reality, it's not. We need to know exactly what that is, so we know if we're balancing a ration, how much distiller's grain to put in there, how much corn to put in there to meet the nutritional requirements of your cattle, of your herd. So with that, I think we're done.